our interactions, and the next thing we're gonna do is first create our mesh, and then we can create our loading. So coming towards the meshing, I like to create mesh on every single part, but some of them are not quite good looking, depend on their colors. So I need to have some, I need to have some, what do you say, the partitions, so that I can easily mesh them. So the one thing is I would like to partition my angle. So how would like point and normal, I want this point and all the way up to this thing. So create partition, it will create partition here. I like also to create a partition here. So the creating partition will help me to choose a good mesh. And this, so see, the moment you create a partition, the color changes, the good color, blue, red. So the other, some color, when you do have some complicated geometry, so probably you won't be able to mesh it very fine, or the way you want to mesh them, because there are several categories of meshing and all these stuff you need to take care of. So the base plate, yep, looks good. The bolt, I need to also have partitions in my bolt. So yeah, point and normal. So I like this point to create a partition all the way to my, let me see if I can choose normal to that, I'm not sure. So I need to have another options for that, which might be the 3 point. So this is 1, this is 2, and this is 3. Create partition, so it will create the partition in my bolt in this direction. And I will also this cell, shift this cell, turn 3 points. So once again just choose this point, this point, and this point, and create partition. So now my bolt are in these two. I would also like to separate, because now it's act as a single thing, so I would also create partition at this location and at this location. Let's see if I can do that by, okay, select cells, need to select all of those cells. Let me see. Point and normal, probably I'll try it. This is my point, and see, let me see if I can choose this. Right, so it does create a partition the way I want. Yep, cool. Same with this thing, create partitions in all those, and point and normal. So I can choose this point, and I can choose this line over here, which is normal to that point. Cool. So now my bolt looks good for the mesh, and done. Now I need to have exact same thing with my other bolt. Where does it go? Alright, 3 point, 1, 2, and 3, and create partition. Boom. Again, choose those, turn 3 points, 1, 2, and 3. Boom. And again, turn point and normal this time. So this is my point, and that is my normal. Create a partition there. Same with upper, point and normal, choose all those, make sure all of them are chosen accurately. That's my point and normal and done. So bolts, now lower part looks good. I really don't need to mesh that part, or I can even delete that part, but I'm not quite sure. Let's do I have that in my instances? I really don't know. Lower part, well, no, I don't have it. Let's leave it for now. And well, upper plate, and finally the weld. So now everything looks good coming towards the mesh. All right, so in millimeters it gives me an approximate global size of 8. I'm gonna leave it by default, probably not 8, let's do 10. Apply, turn, mesh it, mesh the part, yes. So this is my mesh. I may need to refine it a little. Let's say not 8. Yes, delete the previous mesh, turn, and yes, mesh it, and now it looks okay, but I can take a look in the assembly. Yep, seems okay. The other thing is I can also assign mesh control to it, by the way. Let me see. Hex, I can't assign mesh structured, but it should have, yes. So let's just assign sweep and choose this option, and okay, delete mesh, turn. Let me see if I can apply turn mesh. So now the mesh looks good to me. See, that's how you gonna play with your mesh. We are not going to do a detailed mesh sensitivity analysis, which you should, where you can just vary your mesh, and then monitor the result until the difference in your result is less than 5%, and then you can just go with that mesh. So angle is done. Now the base plate here, let's just keep it 10. Apply, turn, and mesh the part, yes. So I really don't want like those things, so I again come to here, select all those regions, hex, sweep, material, and turn, again come to the mesh part, yes. Now my mesh is good. Coming toward the bolt, just prior to meshing that again and again, I'd like to have it already in sweep. Done. The green one was, by the way, the structured mesh. That is also good. So now the bolt is 3.1. Let's just do it 4 rather than 3.1, just to be, you know, consistent. But we'll see how does it looks. Well, it's pretty good. Yeah, it's pretty good. And also this mesh, let's take a look at the green one. You will find that the green color is for the structured mesh. Okay, so that's one thing. I'm gonna assign all to this, and again 4, apply, turn, mesh the part, yes. And the lower plate, I'm gonna assign first the sweep, turn, probably 10, because just to be consistent with my base plate. Was my base plate 10? Not one. Yep. Upper part and upper part, like so. Probably it's already sweep, but only need to choose this. Not 25, of course. 10 and mesh it. And finally the weld. So let's just try the structure for the weld, just for the sake of trying. So let's say 4, just to be similar to the bolt. Let's see how does it look. So you see the highlighted element have determined to have unusable quality stuff then. So it gives me an error, although it is meshed. but it give me error. So that will be the reason that you won't be able to convert your model. So let's just change this to, instead of structure, to sweep, and delete the mesh. Done. Mesh control 4, apply, done. Mesh path, and boom, it will not give you any error now. Alright, so I believe every part is mesh now, and to me it looks pretty good mesh, very refined mesh. And as always, to take a photo from your mesh to include in your report or research paper, whatever you want. So the model looks good now. The next thing is that I'd like to assign I'd like to have some sets for my interaction, because I want to hold all of those sections to resemble something that was experimentally done, and then I can apply the force here. So there are also two ways to apply force here. I can define a reference point here, and then using the interaction manager I can always choose an interaction surface here to tie that point to the whole surface, and then apply a load to that point. That is one way. The other thing is that I can create a set out of all those points from here to here, and then apply a load on that. Both ways should be fine, but I'm gonna go through the second option. Alright, so let's come towards the, just always minimize this to have a clear track of your model. Where is that sets here? I already have one sets, and that is well, right? So the second set is my, let's say, loading point, and it will be nodes. Continue, select the nodes. So I'm going to select nodes, all those nodes. Just make sure that you do not select any nodes from here. So it looks good to me, and done. I have the set for those nodes, and I also like a set of nodes here just to be for my boundary conditions. It will be fixed, so it will be fix fixed, let's say, boundary condition, and again nodes. Continue, and I like to have all those nodes here, and done. So now meshing is done, boundary condition is done, amplitude. Okay, by the way, I need to, oops, my bad, I need to vary my amplitude. It's not actually 110, it's 50 mm. It should be here. Just delete these rows. So 50, and that's 25, and okay. Coming back towards my step module, edit, should be 25, and okay, and dismiss it. Now let's come to interaction, not interaction, the load module, to create the boundary conditions that we have. Alright, so the first thing is that we need to create, it's a boundary condition here. So it's in the initial step, displacement and rotation, boundary condition 1. Let's name it as a fixed. Continue. So now I have the eligible sets here. So fixed boundary condition, I named it, so that's this one. Continue, and I'd like to make this as all the translational. as fixed here, and I'm going to allow the rotation here. And the second thing is the coming toward the boundary condition, so it will be the monotonic static general step. It's the monotonic loading that I have. It will be displacement and rotation. The eligible set is the loading points. Continue. So what's my direction? It's y, which mean y2, but it is negative direction, which means -1. And what does that -1 means? It means that the load will be applied in this direction, but what kind of load? The amplitude that I have defined, which means the displacement based loading protocol. And I press yes. So as you see, it's downward because I didn't apply it in negative direction, so probably I need to change that. Monotonic, it did. Oops, not negative, it should be positive one in upward direction, and okay, and dismiss. As you can see, my loading is applied in upward direction, so it is applied on every single point that I have in my mesh. Let me come toward my mesh here. See, every single node that I have, the load is applied. Alright, so now I think everything seems to be alright. So in the next video we will run our model and see how things goes.